Hello, everybody. Welcome to today's lesson. Let's go over today's lesson objective. So today we will determine if a table or graph is using an additive numerical pattern or a multiplicative numerical pattern. All right, so we have two success criteria. So our first one is we can determine if a table is using that should be an additive or multiplicative numerical pattern. Or the second one is I can determine if a graph, I'll go ahead and edit that in our notes. If a graph is using an additive or a multiplicative numerical pattern. All right, let's go ahead and jump into our vocabulary. So our first one is addition. So addition means combining two or more numbers, right? So if we have 5 apples and we're combining them with 4 apples, we're going to get 9 apples. That whole process is called addition. Now let's go into what is multiplication. So multiplication is combining equal amounts. The difference between addition and multiplication, we're combining with both of them, but for multiplication, we need to have equal amounts or equal groups. So we have 3, which is the same number as 3, which is the same number as 3, same number of 3. So we have 4 groups of 3, so we're going to combine all of them, which is going to give us 12. All right, let's go ahead and talk about what is a graph. So a graph is just a visual way to represent data. So if we look at data, it can be really, really hard to read. A graph just makes it easier for us to read it and makes it more visual. So there's different types of graphs. Here are different kinds of graphs right here, but they're just a visual way to represent data. All right, and last but not least is an input-output table. So an input-output table is a table showing a numerical relationship between an input and output. So with an input-output table, is basically what are we putting in, which is our input. We're going to do some sort of rule, and that's going to give us an output. So for example, this input-output, I put in 1. My rule is to add 4, and my output is 5. So 1 plus 4 is 5. So that is an input-output table. All right. I forgot one. We have number pattern. So number pattern is just a group of numbers that follow a pattern or a rule. So for example, with our hot air balloons, our first one is 15. We're going to go ahead and add 3. That's going to give us 18. Then we're going to go ahead and take 18, add 3. That's going to be 21. And then we keep going over and over and over again. All right. Now, I forgot 2 vocabulary words. Our last one is ordered pair. So an ordered pair, we use this on a coordinate plane. So is 2 numbers written in a specific order and written in parentheses. Those are these things right here. Those are parentheses. And it's used to show a point's x coordinate and y coordinate on a graph. So x, y. So we have 3 as our x coordinate. So if we look over here on our x-axis, we're going to go over 3. We're going to start at the origin and go over 3. 1, 2, 3. So this is 3. And then our y is telling us we need to go up 4. So this vertical line going up and down is our y coordinate. So I'm going to go ahead and start from here and go up 4. 1, 2, 3, 4. So together, that is going to be our point. That is our ordered pair. It shows us the placement of the x and the y. All right. Now let's go ahead and go into our practice problem. So we're going to find out, is this pattern additive or multiplicative? So over here we have an input-output table. So whenever we're looking at an input-output table, our x is always going to be our input, right? So x is going to be our input, and then y is our output. So what I'm going to go ahead and do is I got to figure out what this pattern is. So let's look at our x, what we're going to be putting in, and we got to figure out how we get to y. So I know I'm going to have y is going to be equal to 6, right? So I got to figure out, okay, y is going to be equal to 6. In order to get to 6, I have to input my x, which is going to be 1, and I got to figure out what can I do to 1 to get to 6. So as I'm thinking about this, I know it could be one of 2 things. I could either take 1 and add it to 5. So that could be option 1, x plus 5 equals y, right? Or I know that I can also do 1 times 6, and that's going to equal 6. So my other option is that y is going to equal 6 times x, right? So let's go ahead and try and figure out how. Let's go on to our second input and see if we can figure out this pattern. So I know my second input is 2. So I got to figure out, okay, so if I take, let's use this one, x plus 5. If I input x, which is 2, I'm going to add 5. That is going to give me 7. Okay, so I'm looking at my output right here. My output needs to be 12. So I can already see, okay, I can't add 5 to my x to get to 12. But let's go ahead and try our second rule, which is y equals 6x. So if I take 6 and multiply that times 2, that is going to give me 12. Okay, let's go ahead and look at our output over here. Oh, that is 12. So it's looking like, okay, so we have a rule, y equals 6x might be our rule right there, right? So let's go ahead and see if it's the same thing for 3. So we're saying 6 equals, or y equals 6x. So if I input 3 for my x, so 6 times 3, that's going to equal 18. Okay, so that one is right. Let's go ahead and try it for 4. So if y is 6 times 4, that's going to equal 24. Okay, so that one's correct too because my y equals 24. If I do the same thing for my 5, so y equals 6 times 5, that's going to equal 30. That's correct. And then if I go ahead and do y equals 6 times 6, that equals 36. Okay, so it looks like the rule that I'm going to be following is y equals 6x, or y equals 6 times x. So that is an example of multiplicative because I am multiplying to get my output. So I'm multiplying 6 times x. So this rule is multiplicative. It is not additive. All right, now let's go ahead and look at what this is going to look like on a graph. And these points are really small, so let me make them a little bit darker. There we go. All right, so I'm going to go ahead and look at this graph. Now, I have a graph, but I have to go ahead and get these coordinates down, right? So let's start with this first point. I'm going to do this in red. So let's figure out what our ordered pairs are. So my first point right here is I'm going to look at my x, which is on the bottom. This is my x-axis, and this is my y-axis. So first I got to do my ordered pairs. So my x, if I look at my first one right over here, is I go down, that is 1. So x always goes first in our ordered pair, so 1. Then let's look at my y. If I go over, that is 7. Okay, so that's my first ordered pair. Let's go ahead and do our next one. I'm going to highlight this in orange. So let me go down to my x, which is 2. And then I'm going to go over to my y, which is 8. All right. Now I'm going to go ahead and do my third point over here. So I'm going to go down to my x, which is 3. And then I'm going to go over to my y, which is 9. Okay. Now let's go into my fourth point. I'm going to put that in blue. Go down to my x, which is 4. And then I'm going to go over to my y, which is 10. And then my last point, go down, that's 5. And then my y is 11. Okay, so now we got to go ahead and try and figure out the rule of how I go from each point. So let's look at our input. Our input is always going to be x. So my input is 1. So I know that y is going to equal 7, right? Because that's my output. So I got to figure out, okay, how do I get from 1 to 7? So if I look at 1, I see that I can go ahead and do 1 plus 6. That could equal 7. Or I could also do 1 times 7. That is going to equal 7. So now let's go ahead and see what the rest of our points are going to look like. So it's looking like if I go ahead and do my y, and I'm going to do my first one. So I'm going to take my x, which is 2. And I knew from my rule I wanted to add 6. And I want to see how much that is. Okay, that's going to equal 8. So it's looking like, okay, so it could be my addition problem of x plus 6. That could be the rule we're looking at. Okay, so we have that. Now let's look at our second option. So our second option was x times 7. So we're going to go ahead and put down 7x, and let's see if that's true. So I have my x, that's 2, and I'm going to do times 7. That equals 14. That is not the same as 8, so that is wrong. So I'm going to go ahead and check with my rule of x plus 6. So let me go ahead and clear some of this out because I know it's getting kind of messy over here. All right. Now, so we're going to go ahead and test out the rule of x plus 6 and see if that applies for all of it. So I'm going to go ahead and look. I know y has to equal 8 because that's my output. So what rule can I use to get to 8? So if I do my rule of x plus 6, I'm going to input 2 for x plus 6. That is going to give me 8. So that's correct. Let's go ahead and check with 3. So if y is going to equal 9, so I need to know, okay, does my x plus 6 equal 9? And it does. Let's go ahead and try our last two. So y has to equal 10, which is going to be equal to, with our rule, x plus 6 is going to equal 10. All right, that works. And let's go ahead and see if for this one, y is going to equal 11. So let's see if we take our x and we add it to 6, that is going to equal 11. So it looks like this rule of x plus 6 is correct. So we're adding, so this is an additive pattern. We're not multiplying, we are adding to get from our input to our output. All right, so I hope this was helpful. Let's go ahead and review our lesson objective. So today we determined if a table or graph is using an additive numerical pattern or a multiplicative numerical pattern. All right, I hope this was helpful for you all. I hope this was helpful for you all. And I'll see you all next time. Bye.